Okay, here's the really fun puzzle. Going from only a partial graph to an equation to describe the entire sinusoid. Here's our setup. We have a figure showing a quarter cycle of a sinusoid. Write a particular equation for the figure. Okay, now remember there are 5 pieces of information we need. The 4 variables and the choice of a function. Since we have a quarter cycle, let's take a look at both the sine and the cosine and try and figure out which quarter of the cycle we're being given. Now, if I take the sine function here on top and I look at one period, which goes from here to here, I can cut that into 4 equal sections. Through the high point, through the place where it crosses the axis, and through the low point will give me 4 equivalent sections. I can do the same thing here with the cosine, starting at the y-axis and cutting into 4 sections from the maximum to the maximum. Here we can now try and figure out which piece this curve that we're given matches up with. And my first inclination is to see that this piece looks a lot like this piece on my sine function. So I'm going to use the sine function as my model. I've made my choice to work with sine of theta. Now I need to pull those other 4 pieces of information based on the values that are given to me on the graph. Now, if I look, I can see that I'm using that lower half of the sinusoid, which starts in this section here. That section starts at the midline and drops to a minimum. So this 6, 4 tells me that the 4 is going to be my midline. If I continued this graph up and over, I could see how my sinusoid is going to play out. So the 4 is my C value, or my sinusoidal axis. Now, the other values we want to work with are the amplitude, the distance above and below the midline. So I can see that since my midline was at 4 and I dropped to -2, then my amplitude will be 4 minus -2, or 6. So I have now dealt with the vertical information, the vertical translation and the vertical dilation. From there, we want to talk about horizontal effects. Now, if we think about how long it's going to take for this image to repeat itself, I'll recognize that going from x equals 6 to x equals 8 took up 1/4 of the cycle. So in 2 units, I traveled 1/4 of the entire period, which means that my period would be 4 times the 2 units. And I use that information to calculate the b value for my equation, because we know that b is 360 over the period. So in this case, that would be 360 over 8, which turns out to be 45. Almost there. I've got A, B, C, and my choice of function. I just need to find my d value. How far have I translated my function to the left or the right? And here we have to be careful, okay? Because if we look at our sine function, we notice that it touches the sinusoidal axis at the beginning, in the middle, and at the end. And we have to recognize that what we've done is chosen that place where the sinusoid drops down across the sinusoidal axis. But we want to measure our phase displacement from where the sinusoid rises across the sinusoidal axis. And we want to choose the first place where that's going to happen. So that would be this location over here. Now, to find that, we can look at our overall period, which we determined was 8, and recognize that from the original point of 6, 4, if we travel backwards to this place where the graph rises across the midline, that's half of the overall period. So we've traveled 4 units back from the x equals 6. So this would be x equals 2, and that distance from the y-axis would be my phase displacement, or my d value. So our d value is 2 units. We now have all the information we need for the equation. We have our a value of 6, our b value of 45, our c value of 4, and our d value of 2, along with our choice of the sine function. We put it all together, and we see our equation.